Good morning, students. Welcome you all to this online lecture series on VLSI design, the subject of your current semester. In the last lecture, we studied design representations, which is the concept of VLSI design. Now let's start our new topic today, that is various applications of VHDL. So let's continue with this new topic. As you see on the slide, in this online lecture of VLSI design, we shall be talking about various topics related to applications of VHDL or VLSI. We shall discuss what are combination circuits, what are their types, why they are used. Then we study thoroughly various circuits of multiplexer, demultiplexer, encoder and decoder. Since this topic is very lengthy topic, so we shall cover this topic in two phases, part A and part B. So now let's study the first topic of today's discussion, combinational circuit. Let's move to the next slide. As you see in the slide, for better understanding of this topic of combinational circuits, we can further explore this topic in various major categories. These are basic definition of combinational circuit. Then we study what are its main purpose. Then we study about its block diagram configurations. After that, various examples shall be taken up for better understanding of the topic. The block diagram along with the VHDL code shall be discussed at the end so that we can have better understanding of the topic. So let's explore this four in detail now. And we start with our main topic, combinational circuit design. Now the first question comes to our mind, what is combinational circuit? The definition says that it is a circuit made up of different gates, or we can say that it is a logical circuit where different gates are combined. Now what is the purpose of this design? These logic gates are considered as decision making circuits, and the output of the combinational circuits depends only on the values at the input at any time. So we can say that these combinational circuits do not make use of any memory or storage device for its processing. Now in order to understand this topic in better way, let's take an example of combinational circuit of any logical gate. So here we have taken NOR gate. As you see on the slide, an example of the combinational circuit is shown. This is an example of NOR gate logic. As you see its block diagram on the right side, the truth table is written along. Two inputs are there, A and B, and one output is there, that is Y. Now the inputs can have four combinations as shown in the truth table. These can be 0, 0, 0, 1, 1, 0 and 1, 1. So output will be high only at one combination of A and B, that is when both are low, when both are 0, 0. So the logical equation of NOR gate shall be Y is equal to A NOR B. Let's observe its block diagram. Now study its VHDL code. As you see on the left side, the VHDL code for NOR gate is shown. Initially the library declaration is done, and then entity is defined for NOR1 gate. In this part, two inputs A and B and one output Y is defined there, and then entity is closed. The architecture part covers the basic logic as shown for final output Y. This Y is the logical combination of inputs A and B for the logical expression Y is equal to A nor B. And then this architecture is closed. This completes its VHDL code. I hope you have now understanding of this topic of combinational circuit design. Now let's move to the next topic for the study of topic multiplexer. As you see in the slide, again we can break this topic in 4 parts, starting from its definition, then main purpose, then block diagram, and then VHDL code. Now we start with the first topic, that is, what is multiplexer? The definition says that a multiplexer is a data selector. This means it has multiple inputs, out of which only one is selected at a time. How it is selected? It is selected according to the logic of select lines. Now what is the purpose of this design? The basic purpose of this design is that these are used to increase the efficiency of the communication systems. It must be kept in mind that a multiplexer allows the transmission of data, which can be audio or video, from different channels over a single line. So we can say that a multiplexer is that combinational circuit which is used to select data from single input at a time with the help of select lines and transmit it to the output. Now in order to understand this topic, let's take an example of multiplexer shown on the next slide. As you see on the slide, an example of multiplexer is shown. This is an example of 2:1 multiplexer circuit. See its block diagram on the right. 2 inputs are there, that is W0 and W1, one select line S, and one output, that is Y. Now the inputs are selected according to the select lines logic S. Any one input from W0 and W1 will be selected and connected with output. Observe its block diagram. Now let's study its VHDL code. As you see on the left, the VHDL code for 2:1 multiplexer is shown. Initially the library declaration is done, then entity is defined for a multiplexer called mux2 to 1. Then 2 inputs W0 and W1 and one output Y is defined there, and then entity is closed. The architecture part covers the basic logic as shown for final output Y. This Y is the logical combination of inputs W0 and W1 along with select line S. Then the architecture is closed. This completes its VHDL code. I hope you have now understanding of this topic of multiplexer. Now let's move to the next topic for the study of demultiplexer. As you see on the slide, 4 parts we will cover. First part is what is multiplexer. The definition says that it is a device that takes a single input line and routes it to one of the several output lines. So its action is just the reverse of multiplexer. Now what is the purpose of this design? The basic purpose of this design is that A demultiplexer is used to connect a single source to multiple destinations. It must be kept in mind that the main application area of demultiplexer is communication systems. So let's take an example. As you see on the slide, an example of 1:4 demultiplexer is shown. See its block diagram on the right. One input is there, that is F. Two select lines are there, S0 and S1. And four outputs are there, that is A, B, C and D. Now the input F is connected with particular output through single channel as per the select line logic provided by S0 and S1. Observe its block diagram. Now study its VHDL code. As you see on the left side, the VHDL code for 1:4 demultiplexer is shown. Again, initially the library declaration done, then entity is defined for demultiplexer, which is called as DMUX124. Then inputs F select lines S0 and S1 and output pins A, B, C, D are defined there. And then entity is closed. The architecture part covers the basic logic as shown for the final outputs A, B, C and D. These outputs are connected with input according to the if-else logic defined by select lines. Since four combinations can be there, S0 and S1, that is 00, 01, 10 and 11. So only single output from A, B, C and D will be connected with input F. Then our architecture is closed. This completes its VHDL code. I hope you have now some understanding of this topic of demultiplexer. Now let's move to the next topic of demultiplexer. Now let's move to the next slide for the topic of encoder. As you see on the slide, again we start with a basic question, that is, what is encoder? Its definition says that it is an electronic device that is used to convert an analog signal to digital signal. So one of the classical example of encoder is BCD codes. Also, an encoder is a combinational circuit that performs the reverse action as that of decoder. Now what is the purpose of this design? The basic purpose of this design is that these are used to translate various parameters such as speed, direction, distance or position into digital signals. Now let's take an example. As you see on the slide, an example of encoder is shown. This is an example of 4 to 2 encoder circuit. Its block diagram is shown on the right. 4 inputs are there, that is A0, A1, A2 and A3, and the 2 outputs are there, that is B0 and B1. Now the inputs A0, A1, A2 and A3 are encoded to form the 2 outputs B0 and B1. This can be seen in block diagram. Now let's study VHDL code. Initially the library declaration is done. Then entity is defined for encoder called encoder 1. Then inputs are defined in bit vector form, that is A from 0 to 3 and B from 0 to 1. And then entity is closed. The architecture part covers the basic logic as shown for final outputs B0 and B1. These inputs A0 to A3 are encoded with logical OR logic to form B0 and B1. In this way, the architecture is closed and the VHDL code completes for this encoder. I hope you have now understanding of this topic of encoder. Now let's move to the next slide for the study of decoder. Now first question, what is decoder? It is a combinational circuit that has n input lines and maximum of 2n output lines. Now what is the main purpose of this design? The basic purpose of this design is that it is a circuit that is used to change the code into set of signals. It means we can say that a decoder has just the reverse action to that of encoder. Now in order to understand this topic in better way, let's take an example of decoder as shown on the next slide. As you see on the slide, an example of decoder is shown. So this is an example of 3:8 decoder circuit. See its block diagram on the right. 3 inputs are there, that is I0, I1 and I2, and 8 outputs are there, that is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Now the I0, I1, I2 are decoded to form the 8 outputs starting from Y0 to Y7. This can be seen in block diagram. Now let's study its VHDL code. As you see on the left side, the VHDL code for 3:8 decoder is shown. Initially the library declaration is done, then entity is defined for decoder called decoder 3x8. Then inputs are defined in bit vector form, that is I from 0 to 3 and Y from 0 to 7, and then entity is closed. The architecture part covers the basic logic as shown for the final outputs Y0 to Y7. These 3 inputs starting from I0 to I2 are decoded with case statements with a 3-bit logic starting with 111, then 110, 101, 100, 011, 010, 001 and 000, and then architecture is closed. This completes the VHDL code of this decoder. I hope you have now understanding of this topic of decoder. This was all about today's topic of applications of VHDL, where we covered part A today. In the next lecture, as you see in the next slide, we shall be covering part 2 of applications of VHDL. So we shall cover various topics such as code converters, comparators, Boolean functions and their implementations, sequential circuits, registers and counters. Thank you.